Hello and welcome to Lesson 1 on Exponential Notation of Module 1 in Engage New York. Today is going to be our first lesson, and we are going to start by talking about exponential notation. The first thing that I want to point out to everyone is what exponential notation means. So we're going to write a little numerical example here. Of 5 to the 7th power. This is exponential notation, meaning there is what we call a base number. That's a big number. So in this case, our base is 5. And then there's an exponent, and that's the small number. In this case is 7. Sometimes the exponent is also called a power. And what that means, it does not mean 5 times 7. It actually means 5 multiplied by itself 7 times. So what we want to do, instead of writing it out like they show in this example here, 5 to the 6 means 5 times 5 times 5 times 5 times 5 times 5. We want to write it in shorthand or exponential notation, meaning 5 to the 6th power. Something to point out is that we can write fractions using exponential notation as well. What we have to make sure of when we use the fractions, though, is that we use a parenthesis when writing it so that we know that 9/7 is getting multiplied 4 times both the numerator and the denominator. Otherwise, it might be a mistake that just the numerator gets multiplied 4 times. Okay, so we are going to start right away with our exercises here and knowing how to do this. So for exercise 1, we have 4 times ... times 4 7 times. Well, that ... is just signifying the same thing that is going to be in the middle. So what we're looking for is the exponential notation. So 4 is our base number coming from the top here, and 7 will be our exponent. So we write that as 4 to the 7th power in exponential notation. Moving right along, the difference in exercise 2 is that now we have a decimal of 3.6 as our base, and that's actually totally okay. And our exponent is already given to us this time of 47. We would not want to write 3.6 times 3.6 out 47 times, which is what makes exponential notation so great. The blank this time is here, so we have to fill that in with our exponent of 47. As we move down the page to exercise 3, there's now, you'll notice, 2 things that are a little bit different, and that is that we have a negative and we also have parentheses in there. And those parentheses are going to be very important when it comes to negative numbers, just as they were important with the fraction. So we're going to leave the parenthesis on our negative 11.63 as our base. And this time it says 34 times, so we will put 34 as our exponent. And that is how the basics of our exponents. So we're going to actually skip a couple of them. We're going to skip 4 and 5 due to the time of the video. And we're going to go on to 6 because 6 is where we now hit a fraction again. So 7/2, 21 times. What we have to do is we know 7/2 is our base, and we know 21 is our exponent, but as I explained before, we want these parentheses to be around every fraction so that we know that 7 gets multiplied 21 times, and so does the 2. And moving right along, so 7 and 8 are very similar. Where students start to freak out a little bit is when we hit exercises 9 and 10, and the reason I think is a little obvious, because 9 and 10 both have letters. Well, guess what? You get to do this the same exact way. So just because there's a letter x times x times x 185 times, we already know that top number is our base, so we're going to use x as our base. And 185 times is our exponent. And that's the answer in exponential notation that we're looking for. Similarly, at the bottom, exercise 10, now we have 2 exponents. We have x's on the top, and it says x to the n power. So what that means is that this n is the number of times that we would be multiplying. So that's our first concept, is writing in exponential notation. Okay, so we're moving right along here. Our next page we're going to hit is page 2. So page 2 should start with exercise 11. Let me make sure that I have it on screen here. And exercise 11 moves on to our second concept, and that is a pattern in what we see happening here. So if you have a calculator at home, you can type this in your calculator exactly as shown. -1 in parentheses raised to the 12th power. And most of us will have parentheses on our calculator, and we'll have this little caret key, and then we'll hit equals there. And if you do that, you will see that it equals -1 to the 12th power is actually +1. And similarly, we can do that same thing in our calculator for -1 to the 13th. In parentheses, caret 13 equals. And when you hit equals, it equals -1. So the question is, will these products be positive or negative? And we've already done it. So we know that this is going to be positive. The question is, why? And this one's going to be negative. What's the pattern? Why is this one positive and why is this one negative? And I want you to scroll back and think about something. If you do -1, just -1 times -1, a negative times a negative will give you a +1. But if you do -1 times -1 times -1 with 3 of them, well, this is +1 times -1, and you end with -1. So here's the thing. 2 positives will cancel out and make, or 2 negatives will cancel out and make a positive. But if you have this extra one, then it's going to make it negative. So the reason that this one is positive is because we have an even exponent. The reason that this one came out negative is because we had an odd exponent. Okay? So positive is when we have even exponents, and negative is when we have odd exponents. And that is provided that your base number is negative. If the base number is positive to begin with, then we don't worry about this rule whatsoever. So moving down to exercise 12 then, with that rule in mind, it's very easy to answer the questions now. Is it necessary to do all of these calculations to determine the sign, meaning positive or negative? So I'm kind of going off the rails here and not answering the question, but my question for you is, will this come out positive or negative? -5 to the 95th power. Is that going to be positive or negative? Not what is the answer. Well, 95 is odd, so that this is going to give you a positive, or I'm sorry, whoa. This is going to give you a negative answer because we don't have an even number of negatives to cancel out. So odd exponents give you negative. In the bottom, this exponent is even, and so it's going to give you a positive answer. And that's something that we will use throughout this chapter. Okay, we are moving this video right along. We're all the way to the last part of our notes already, and that would be exercise 13 and 14. And so we're just going to fill in the blanks here now that we know. This is just worded slightly differently, and I'm going to give you the key words. So if n is a positive even number, okay, so this exponent is even, it tells us, then -55 to the even power has to be positive. Even exponents are positive. If it is a positive odd number, then -72.4 to the n power has to be negative. Okay, because this guy is telling you that's odd. Okay, last but not least for these notes, it says, Josie says that negative 15 times dot 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 times negative 15 6 times is negative 15 to the 6th power. Is she correct, and how do we know? Well, if you type this in your calculator, you will find out that she is not correct. But how do you know? That's kind of the question we're really looking for. So if you do this out with as shown, if you type in negative 15 caret 6, it is going to give you a negative answer. And that would be wrong, because we know that this is an even exponent, which means that this should come out to be positive. Okay? And the way we get it to work out is we use the parentheses. Her mistake is that she forgot those parentheses. If you use that, you type it in your calculator, then it will come out positive. And this is the correct way. So we know that she was incorrect because she forgot to use parentheses on her exponential notation. Okay, the assignment for my class tonight is going to be to do page 4, the problem set, numbers 1 through 6. I will be collecting or at least spot checking those tomorrow, or trade and grade. Good luck on the assignment. Thank you for listening, and we will put a new one up tomorrow.